Okay, so I already created the project for the test and all that. Okay, first you need to like take the vanilla animation files and duplicate them for your project. That is your add-on. So we're basically going to take all of the player ones. And then overwrite in animation course. And then you have two animation workspaces, this one and this one. We don't want to modify the player inventory one. We want to modify the player main one. So just double click on it and all that. In okay, so yeah, you have the workspace here. You have all the controls here and all that. The main ones, well, is the viewport and the player. The animation graph part, which is this. You can see the mouse, right?
Yeah, we
Yep.
can see yes.
Mm-hmm. Okay, and the properties. And when you select something in any of the panels here, whatever you selected, its properties are going to show here. For example, if I select something in the animation sets, and if I double click on it, it's going to play the animation, and then you're going to see the animation events here. It only has one, this one here. And it will show the properties of that here. The same for the nodes in the animation graph. If you click on one, you can see the properties of each one. So just keep that in mind that this one is where you actually modify the properties of everything, and you have to select it. If you select multiple, then it won't work. It only works with only one selection. Okay, so let's play the files first. If you check the files, you probably notice a file that ends with an extension of ASI, and that is for animation set instances. And each file is basically groups of animation names and their definitions for each animation file that it goes through. And you have a main one, and then you can have other animation files that inherit from other ones. And this is useful for when you have, like, for example, different weapons. You want different animations to be played based on that weapon, on weapon A or weapon B. And that can be running animations or just reloading animations, changing them for when you have them on your hands, for example. So that's the purpose of the ASI file, and that's why there is a lot. Like you can see the rifle ASI here on ARM. So when you have a rifle, it kind of like takes to this base one. And you can see them here in the workspace as well. For example, let's play. I'm going to go slower in a bit, like each one. I'm just showing everything right now. So if
The
you
master control one's lower. Lower. Yeah, there.
So if you play this one, like basically it's going to play like if you were in the game, and then you will have to control it. But in here, you do not control it with scripts. You go to the controls, and here controls you are going to find the variable, the commands, and you can change them, and it's going to change the state of the entire state machine here. So it's state based. So just keep that in mind. Like you are going to enter a state, and then if you want to do something else, you need to exit that state properly. So you need to be very aware of the logic of the entire graph if you want to do something, and not have like issues like the player suddenly becoming like some numb or something. So in here you can change the variable and start seeing like with effects and all that. Let's make it so that we're basically holding a weapon. And it says here like animation missing, all that. That is most likely because well, it's not most likely, but you can see that here. This is the main animation file, animation set instance file, and you will see that the group here and the definition for this animation is here, but it is not set to an animation. If you look this up here. So in this one is for a weapon, so go to like the one for a specific weapon that you want. And you will see that when you switch, it switches to the correct animations.
Oh,
So they are not using a very big file, and you have to like have very specific names for them. You know, you can have like, let's say, some identifier for an animation called like, I don't know, weapon race, and then you just change the animation file in that name, like that is tied to the name, so that you have like smaller files and everything is more neat. And when you go here to like an animation instance that is inheriting from, I don't know, you can inherit from one or more animation set instances. The ones that show green are the ones that are being overwritten. And these ones are the ones that are not overwritten, but they are defined in a previous animation set instance that this one is inheriting from. And if you want to modify the animation here, just click on it once. In here, you can set the name, or you can go to File Browser, search for an animation here, select it, and then change the controls here. And then you set it and then change. I don't know which animations can be. Okay, so the animation set instances, is that clear right now? Because it's a key one. I am asking if someone has a like problem understanding that one still, or is that clear?
yeah.
Okay.
Far so good.
For the one that asks about weapons, that one is important to know. And it's very basic. There is not much to it. Most of the files that you see here are basically that and the animation graph sheets and the animation graph itself. So in the animation graph, you have like the main graph. And then you can have multiple, you could say, modules that are the sheets here. In those, you can use basically group logic. Like for movements, idle, it can be whatever. It's just kind of like a grouping. And all of these modules are going to be tied to the main one. So you can access everything from everything.
So, sir, I have a question, please.
Mhm.
Yeah, if I want to edit the model or import a new model for a car, I use the VBX one in the files. Is that right?
Can you repeat? I'm having trouble with the accent.
Yeah, if I want to like edit the model, I should use the VBX in the files.
If you want to do a model,
Yeah, to create like a new car.
just basically import a FFX here. Well, not here, but in the main window.
In Blender.
You can use the Blender plugin as well and export it as TXO, and then the TXO you can take it here, and import it as XOB. The TXO is basically the unbinarized format. You know how you have like mlots and odls? The TXO will be the mlot, and the XOB will be the odl, and it will be the one that the game uses. For animations, there's something similar as well. You have the TXA, and that one is basically the unbinarized one, and ANM is the binarized one. For vehicles, the animations here, they are done through an animation graph, pretty much the same as with the player. And this is very different from how it is in DayZ and ArmA. In DayZ, you can only use the animation graph for players or characters that includes AI. But for vehicles, you still have to do model CFG animations in ArmA and DayZ. In here is very nicely, and you can actually synchronize both of them at the same time here. You will see that you have the when you open one, for example, let's open one for a vehicle.
Salut les gars. Allô?
Hey, Jacob.
Yeah.
Do you think it is an animation events file missing? As in DayZ.
There's an animation events file missing for what, sorry?
I tried to open this one, and it, and it failed to open.
Well, that's just like DayZ.
Yeah.
Just create a fake file there, or just remove it from the Oh no, you can't remove it.
You can duplicate all of them, like you see it right now. You check.
Oh yeah.
Okay, so
Yeah, you
just to finish with this and all that. Okay, so coming back to the animation set instances is just basically a group of names of definitions, and in those definitions you can place a specific animation file on them. And then you have multiple ASIs, and you can change them whenever you want to change those definitions to something else. And you can use that for vehicles, for different animations, for when you are entering a vehicle, or when you have a weapon, or whatever else. Like you could have like a character that it has certain animations for, let's say, when it has some suit or whatever, and you want to change it. Let's say that it has like some suit that is very heavy, and you don't want to make a new state machine or blend stuff and all that. You just want to change animations. When you do that, then you could use another ASI that inherits from the main one or another one, and change the animations there. And then,
so are you familiar with the bulldozer in ArmA 3?
with ArmA 3, no.
But it's the same thing in DayZ. They use a bulldozer to see the models in game.
Oh, yeah.
Yeah, yeah. If you can see my screen, please. I found this car on GitHub, the simple one, and if I want to try it in game, I can't. Can you tell me why?
open up a world. So the second icon, you click that.
Open any world there, or just create a new one. Open
The folder icon.
the folder icon, and open a world, and then place it in the world.
Yeah, click load world.
Wait. Say it again.
Click load world.
Where is it? That's
In file,
file,
load world.
load world. Okay.
Click ArmA Reforger.
Mm-hmm.
Worlds, and then find a world to load. So just go to Eden.
Eden.
Yep, and just like that. It'll take a while to load. Drag in the car to where your player would spawn. I don't know where that is, and you should be good from there.
Okay, how to to create a mood in ArmA Reforger? Like to try it like in game.
This tutorial's more for animations right now.
No problem. Thank you. By the way.
I have question, Mario. There will be no problem when more mods will create more animations for character, like in Daisy is problem still.
Wow. Wait, that tool was the model tool? Just joined the call. The tool that not Mario, the other guy was showing. Is that the model tool?
It's basically for preview and changing like certain parameters on the models themselves, and also modifying the materials. So you have a material editor as well, and you can preview everything on real time with it. But you cannot like modify models like in a 3D suite and all that. It's just basically preview setting some parameters there for the configs, for the config of the XOB or the EMAT.
That looks awesome. Like it looks better than ArmA 3 model maker and stuff. Wow.
Okay, so in here, let's go to the state machine now. That's the animation graph. And basically, it's basically just the logic of the animation. It's also the logic of the characters. So like for the controller of a character, you can basically just control everything here. You can also control it on scripts. It depends on how you want to implement it and all that. I would recommend to do as much as you can here, because the animation graph is replicated on all clients automatically and very efficiently. So it takes away all the work that you need to do in terms of networking. And there is a catch there. It is not replicated the same as with normal, or like let's say that you are in a server and you the client, you are doing something with your character. Everything that you are doing is going to be sent to all the other clients, but on your client specifically, you need to be processing the stuff that you are doing client side. That comes with also the processing the animation stuff client side, and then also server side. But for other clients, you do not need to process anything client side for your client. It's only for your very own client. I hope that makes sense. Is that clear? Because that affects a lot on how you do stuff for this.
So you're
on
only
the design.
processing your actions with your player.
Because think of it this way: you as a developer, you want the player, to feel like everything's smooth for its character. So
I got you.
So you want to process everything there and then send it to server, or just do a cross check.
And using the animation graph makes it easier, so we don't have to worry about that. We just focus on this bit. Okay, gotcha.
Okay, so here is just basically a normal state machine. Everyone here knows what a state machine is, right? If someone doesn't know, I can explain it. No issues there. I take that as a yes.
Yeah.
Okay, so you have the state machine node. Like everything is a node, everything is considered a node. And the state machine itself, which is this entire thing, is considered a single node. And then in this single node, you have other nodes in it, which are the states. Each state it also has transitions and all that. And then you have other nodes and all that. Let's explain the state machine first. And basically, these ones are the ones that control the flow. So these ones will not by itself play an animation or blend stuff together. Well, they can blend stuff when you are transitioning. But like when you want to play an animation or blend animations, you are most likely going to do it through like nodes and all that. There is also a way of handling some logic with using state machines, but the best way is state machines. And you have in the state machine, when you play it, let's say that you're going to play it and you don't have any transitions. When you enter the state machine, it's going to play the first node that was created if you didn't set a condition for any of the nodes. You can see in properties, as I say, like properties is your friend here, is used for everything. If you select it, you will see that in start condition, it has nothing set to it. So it goes to the default value. And you can see that none of them have it. And this makes it so that when you start this, and there is not any... Okay, so you have like two types of transitions. You have the any transition, which basically makes it so that when the state machine is going to be processed, it checks all of the any transitions first, and if one becomes true, then it's going to enter that state machine independently of if it's already in another one. So use the any one to enter a condition like in that way, globally. It's checked globally when you are in the state machine. Just be careful to not make it so that it's always true. You will see here that in the any conditions, most of the time, they are set to in the conditions, in the expression of the condition. You will see that it's using this expression, get command equal 1. I'm going to explain what commands are in a bit. Basically, this expression is going to only be true in one frame. And then in the next frame, it's going to be false. So you are not going to have the issue of this becoming true always and then these states being re-entered every frame. So just be careful with these ones. You also have the conditions here in each state. This condition is only evaluated when you enter the state machine. And it will not be evaluated anymore. It's only when you enter it. And if you don't have any condition. So that's the difference between these two. This one has with this one, okay, when you have this start condition, you cannot blend in between transitions and all that, because it's not a transition, it's just entering a state. So if you are playing like some animation here that, I don't know, let's say that the player was idle, and in here you have one where the player is running, it will just literally switch directly to the running one. There will be no blending at all. You can do the blending with this one, with the, well, you have the, you have the duration. The duration is the duration of the blending between the previous context. The context is like some animation that you had previously playing or whatever, or a bunch of them. And then it's going to blend whatever you have in there with the new one that you just entered here. And it's going to take X time, the time that is here, which is 0.6 seconds. And it's going to blend with the spline. So the only way you can do blending like that between states is with transitions. With the start condition is used directly. You can do directly here as well if you just set a duration of 0. Any questions on that?
No, that makes sense.
Okay, you can see here like how it performs. Like if I play it, you will see that I think there's not any transition to this. Let's see. Yeah, there is not. Okay, so if it doesn't show here, so you need to be a little bit careful. If you open the animation graph file here in the text editor, you will see that this one is the first being defined. So the first one that was defined, as I said, is the one that will be played if none of the conditions of these ones are true. By default, each one is false. Well, kind of, they're kind of like, because the first one is not going to be false, if nothing else is evaluated to true. That includes the transitions here. So I will play this one directly, and then we can go here and see, okay, this one is going to be played. There is no transition that is playing that will send you to this one directly, except this one. And we can see this one that it requires the command stream to be fired with a payload of 1. And we can test that by going here to controls, going below, and then search for command stream. It can have a float payload or an int payload. We are going to send it with a payload of an integer 1, and then we are going to fire. If you want to fire, you stick this, and it's going to fire directly. And if we check here, they removed the controls. They're not the same. There was a control before in DayZ Workbench where you can basically just play frame by frame. I will need to see like which one is it here. With the keyboard, with the shortcut. So this one, let me just play it frame by frame. Okay, so let's activate this. You will see that it only evaluates to true in single frame. Then it enters that frame, and then it's gone. Do you see? So it's only true in this frame. And this expression here, this function, get command swim, that's only true when this is true with this payload. It is true with this payload because of this one here. If you want to change that to, I don't know, 3 or 4, and you play it, and you try to fire this with 1, you will see that it doesn't fire. So this is basically just conditionals. There is nothing very special about it. In these expressions, I don't know if the devs are going to post all the expressions that you can use here. I'm going to post all of them anyways here in Fusion Animation Makers. A dump of all of them and how you can use them. And even the return types, like everything. Because there is a bunch. These expressions, anything where you need to evaluate to some value is going to accept an expression. And that expression can be animation variables, commands. With commands, I mean like using this function to evaluate a command. It can be conditionals, or it can just be a straight up number. With variables, you can set variables in controls. So let's say that I want to use the movement speed variable to activate swimming. So what you will do is just type here movement speed. And let's say that I want it to be triggered when the movement speed is bigger than 1. Then just make a bigger than 1. And now you can see here what I was talking about. Do you see what's happening? It's evaluating every time to true again and again and again and again. And it's even creating multiple contexts here because of the blending. The blending takes 0.6 seconds. So it's creating as many as it can when it's blending in between them. So let's say that you want to trigger this state when the variable has reached 0. When the movement variable has reached 1.0. With just doing it this way, you will run into that problem if you want to do any transition. But there is a function that allows you to only trigger it to true when the variable has changed to a specific value in the first time. That one has variable change. Well, I think that was the name. Let me try here. Oh, it actually autocompletes now. That's nice.
You can see what exists now.
Okay, this one, it will check if it has moved. And then whenever you change it, it's going to re-trigger again, as you can see here. But it will not be triggering again and again and again until you change it. So that's basically how you control the conditionals here. And if you want to like do this specific case here, just make sure to call this one or the has variable change to 1. We just check if you changed to a specific value. Okay, and then in the states, if you want to say like which nodes or which path to take, then you set the shell to any other. The shell can be any node, so that includes the state machines. It doesn't include the states in the state machines. Those are internal to the state machine. So in shell here, you can only call these nodes, or these ones, the normal nodes that are outside. When you see like it's calling to a node and there is only a square here, it means that it is calling a node that is outside of the current sheet that you are in at. So if you want to just check it directly without having to search it and all that, just double click on the white square here. And it will send you to where it was linked to. Any questions so far? It can be something that
Those expressions are also working on DayZ, because I see that function
Yeah.
when it's triggered first time.
Yeah, all of them work in DayZ.
Super.
The difference here is that the only difference so far is that in DayZ you only have you have 3 is command functions, and that is command, just to check if a command is active. Is command I, which is to check like the integer value of the command, and is command F, which is to check the float value. In this one, you have 7 in total. So that's the only difference, but the rest is exactly the same. The cosine function is the same, like all of them are the same. Okay, let me keep explaining the states. Oh, you can search states here, by the way. And, well, nodes. What was the master call?
Master control.
Okay, so in here you can see the node group and all that. This is actually new. So far, what I understand from this one is that it's just basically to group nodes, and it doesn't affect the graph at all. It's used for the developer to have everything more organized. The one that actually is important is this one, the child one. So that's basically anything you need to know about start conditions, like that you can use functions. You have these functions that evaluate to some value, and you have conditionals, and you can just have variables or values directly to it or chain together. The time storage, that's for the context. You can see it here, for example. Do you see when it's playing? This here is the context, it tells you what's in the context right now. And you can see that it is evaluating real time, and then you have L time, which is the lower time, which is the time that is basically being evaluated in the lower context, which is basically what's the child of this one, And so it's not always the same. It can be like, this one can be like 47 something, and this can be 2 something. It depends on the logic of when you started some animation or whatever. And there is certain functions, certain expression functions that tell you the value of the lower time or the upper time, the lower normalized time or the upper normalized time, or the remaining time of whatever context or animation that is being played below and whatever. So there is a reason why you have this. It's not used for debugging purposes. I will make an example later on when it's very useful to use the lower time and the upper time. And that's it's very useful for when you, let's say that you have 2 animations and they blend together nicely when they are played at the same time, and you're switching between them with a transition, and you want it to be smooth, like you don't want it to start interpolating that animation A with animation B, with animation A being in, let's say, frame 20 and the other one starting from frame 0, because the blending would make it so that it doesn't blend nicely, it's going to like make some, let's say the leg, instead of being forward, it's going to start bringing it back weirdly. So these times here, they allow you to take the time for, let's say, some animation that is being played, or, well, let's say take the real time and just give it to the other context as a start time, and it will just literally interpolate directly to the same one as before, given that the animations are like the same length. That will be explained more nicely with an example. I will do the example later. But that's basically what you will use start time in the transitions for, as you can see here, start time. The time storage is just real time or normalized time. Real time is just like the time that is playing here, So it's basically this. For the context, if you started a new context at time, let's say 200 seconds here, that lower context is going to be started with real time 0. So each time is relative to all of them. If you set it to inherit, then it just inherits directly the time of the parent. So this one inherits basically from this one. So it will be the same time. You have here is exit. This one, when you take it, it will make it so that when whatever that you were playing here, let's say that you are playing an animation and it's not looped, when the animation ends, this state context is going to end. And if you don't have it to each exit, then it will not leave it will not try to leave the state machine. When you have it ticked, and this state machine is connected to another state machine somewhere else, it's going to detect, okay, this is an exit node. So that means when you finish this node, you have to finish the state machine. So it's going to finish the state machine, and the same thing is going to happen to whatever you have, whatever you have as a parent of this one. And then you can do some other logic. So that's basically what exit does. Pass-through, that's new. I will need to check what that is. When I see what it is, I will post it in here. And then you have tags. The tags here, they are not for you to organize stuff. They are very important. And you have tags for any node, even the internal nodes here, which are the states. And these ones as well. The tags are in all of them. And the tags are basically a way of tagging a specific node in the graph, so that when it gets played, or when it enters to the node, you will have like in scripts a way of telling if you are in a specific point in the animation graph. That's the only way that you can tell if you are in a specific point in the animation graph with the tags. And as long as you are, for example, playing this node, that tag is going to be active in scripts. So you can query it, and it's going to evaluate to true. When you don't have that tag active, then it's going to use evaluate to false. Is that clear? And you can have multiple tags chained together. Like you can have like one tag enabled here, two tags enabled here. All three of them are going to stack, so you can query them. The tags are usually used, for example, in DayZ. They are heavily used for animals. And they are very important there because if you don't set up the tag, let's say that you make the animations and you make everything, and you even set the animation events for the attacks of the character and all that, you will see that even when the animation event for attacking, for when let's say, when a wolf actually bites you, so when it closes the mouth, it will fire an event in animation, and let's say bite. Even though the game is going to detect that, it is not going to actually deal the damage, because the logic of how it was programmed there is so that that animation event, it only gets queried when the combat hit tag is entered. So if you are modifying some animation graph here, and you're creating your own based on that, make sure to check the tags. Because if there is a tag there, it is most likely used to not process certain stuff until you reach that point. So always check the tags. Because then you are going to do whatever you did, and you are going to start scratching your head why something doesn't work, even when you have like supposedly everything. So be aware of the tags. And
Looks like you're reading my brain with my dog, because I have these tags missing with something. Thank you for explaining that.
okay, there is a way to also query tags here. So let's say that you want to start a condition when attack is enabled. So you can basically use is tag, and then the tag name here. Let's say Rust. I mean, it's the same tag that this enables, but just as an example. It says string there, but the same as in configs in RB, that you can have strings that use text like this without the quotes, and this will work here. And also having the quote, it will also work. There is also a way to query events, and that is event. And the same thing, it will evaluate it true if the event is active. Okay, so that's basically all you need to know for state. And the normalized time for when it's playing all that, that makes it so that the lower time of the context and all that, if the animation nodes that are being played allow it or need it, it will make it so that you will get, let's say, that an animation is 1.2 seconds long. That will make it so that you can control it up in the upper nodes, up to that state with a normalized time frame, so between 0 and 1. So if you want to make it twice as faster for some reason, you can just multiply that one, with 2, So it's basically the only purpose that you have for that. Or there is a node that allows you to cycle multiple times through an animation, and you will use normalized time to tell it how many times to cycle. Like if you want it to cycle 2.5 times, just set it to 2.5. And that one requires you to have normalized time, which will be enabled through the state only. The only way to enable real time or normalized time is through a state. So if you are playing some node that requires normalized time, then it will not work. If you are just playing it as a node, you will need a state for it. And those a state machine, because you cannot have states with the state machine. These nodes, they are not considered states. I mean, technically they are, but they are not really states. Any question or someone wondering of something, like whatever? If there is something that you don't understand and you think I will get mad by repeating it, I will not get mad. Just say.
You cut out at the very end when you were talking about how it's technically a state, but not really.
Okay, so the nodes here, internally they are states, because you reach this point and then this sends you somewhere else. And some of these nodes, they actually evaluate stuff and decide where to send you. But in the context of animation graph, these are just considered nodes, and these are considered states. And the state machine is considered a node. So when you see something that says child node and something like that, you will be only able to append a child that is a node. And because states are not nodes, you will not be able to send, for example, this one directly to this. You will have to send this to the state machine, and then through the logic here in start condition or use directly with a transition, make it so that whatever you want it to be enabled when you send this to this, it evaluates to true, then it sends you to the correct path. When this is blue, that's because real time has been enabled to it, or normalized time. So let's say if I set it to inherit again, you will see that it goes back to the gray color. Real-time blue. And there's this clock here. And normal time. And then it will be blue, but with an N here. Okay, I'm going to start with the, okay, so basically this is what controls the flow. You can control flow with used nodes. I will teach how to do that as well. I have not explained the transitions. So the transition is just basically a way to transition from one state to another one based on a condition. In the most basic terms, that's what it is. That's what you can do with it. You have two types of transitions. You have the any transition, which just basically makes it so that when the next frame is going to be evaluated and this state machine is being evaluated, the any transitions are going to be evaluated first, all of them. And then if none of them are true, then it's going to go directly to the currently running state and it's going to check what states are going from this state to whatever other state and test them. You need to be careful because it's going to check them in the order that you have them defined for the state. So the same as having multiple states here and which one runs when you have no transitions is going to evaluate the same here, you know. And one way to check it is going through the actual file and searching for whatever states are tied with a transition to this state.
Can you somehow make some batch script? For example, if you want to be sure that the transition from one state to another state is working, and then, for example, back like if in this workbench you can put some commands and see if this is working instead of clicking between these elements.
There are debug controls.
I don't think I understand what you mean.
I mean, if it's possible, somehow predefine that you won't test if your conditions is working.
Oh, yeah, you have the debug controls here.
Yeah, this.
Basically, you can bind stuff, and when you're playing, you can just, let me play it. You can just check, okay, let's make it turn 180. Oh, well, it didn't turn. Like walk, run, sprint.
Uh-huh.
For some reason, swim. Oh yeah, forgot. Oh, by the way, there is not redo and undo here.
Oh.
Isn't that in Daisy?
It's not. That's not even in Daisy.
Ah, okay.
Okay, so basically that's what controls are. There was a way to evaluate expressions and see what they do in the debug controls before. Sorry, in the controls before, but they got rid of that here. They got rid of a lot of useful stuff. What?
Oh, sorry.
They got rid of a lot of useful stuff from Daisy's workbench in this workbench for some reason. Like, not in terms of features of the animation graph itself, but more of features that aid stuff to developers. So there was in Daisy, there was a way to literally just select and an animation instance, an animation set instance definition, like you will just select it, and then you will go to like, let me go to source node here or something. And you could basically just select this specific animation. You could go here to source, and there was a button here that literally just allow you to just click on it, and whatever you had selected here, it will just paste it here. And that is not here anymore. You have to literally just search for the entire animation here. And you cannot copy the name from here. And if you want to select this one, you have to type damage.heavy f dot, then whatever you have here. And to be honest, the one that annoys to type is this one, because you have to look it sideways. Okay, so the transitions. So as I was saying, is just like to transition to one state to another. You can have as many transitions that are that go from one state to another. You don't have a limit. I would recommend to have try to not have a lot of transitions, because if none of them are evaluating true yet, all of them are going to be processed. So try to also keep that in some small number. So let's explain the transition from one state to another. Okay, so in this one is pretty much straightforward. You have the from state, which is this, to whatever state, which is this one. It can only be states that are inside this state machine. You have the duration. The duration is only for the interpolation between whatever is going to be played here, whatever is played here, to whatever is played here. So that's used for blending between states nicely and all that. If you don't need that, you can just set it to 0. It's in seconds.
You can add debug controls.
I can what?
You can add debug controls. Press this red
No,
stop button at the top. Yeah.
No, yeah, I know. I was talking about the expressions. In DayZ, there was a feature that literally allows you to type expression on it, and then you play the graph, and it tells you the value of that expression.
Like above the thing, above the node. Was it? Okay. Oh yeah.
And that was useful for that was useful for when you need to know what this is evaluating to, because it doesn't tell you. When it says expression and all that, it actually is, depending on the node that you are in, is going to print it here. But in states, it doesn't print it.
Yeah, I see.
Okay, so duration is used for the interpolation. Start time. This depends on if this state is normalized time or real time. If it's real time, then it's just going to be normal time. Normalized time is going to be between 0 and 1, but you can actually have a scale. So if you set it to 5.1, then it's basically going to be the same as 0.1. Then you have the condition, which is to when to enable that transition and transition to the 2 state. And the blend function. And the blend function is just linear, is in, is out. This was blind or something like that. I will need to check the notes. I don't remember what the difference between the two were. And the spring is basically just kind of like, it will behave like a spring when you transition. And the post eval, I forgot what this one was. I will check the notes as well. This is new, the priority. My guess is that, remember when I told you in DayZ you don't have this priority thing, so the transitions that are prioritized, in terms of processing when one is false and all that, is based on the order where you created it. So I guess this one actually modifies that. And this was in DC, right? I think it was, but it was in a drop down. So this for the motion vectors and all that. Basically, whole stuff is going to blend from what direction and all that. You have events here. And this is actually new for states. This is not in DayZ. In DayZ, you can only create animation events through animations themselves. And an animation event is basically kind of like, let's say that you are playing a specific animation. It allows you to tag a specific frame for something. So let's say that you are making a melee attack animation, and you wanted to actually deal you want to actually deal damage when in the animation you're actually supposed to actually make contact with some player or whatever. Or let's say that you have a gun animation for shooting, and you actually want to trigger some effects or whatever when you pull the trigger in the specific frame. You will set an animation for that, so an animation event for that, and you will be able to trigger that, to query that in scripts, and spawn particle effects, or spawn an actual bullet, or play a sound, like do whatever that you want to do in scripts with it. And you will query it by the name. And the user string and user int, they are basically the payloads of them. And it's the same as in commands that I was explaining before, that you can trigger a command and it's going to evaluate a single frame. Animation events it only evaluates in the frame that it was called on. And then when you query that, you can query some information that comes with it. And that's the string here, or the integer. And you can use this, for example, they say that in the animation you shoot 3 times, and the weapon that you have, let's say that it's a fantasy weapon or whatever, and it spawns different effects in all of those 3 times that you pull the trigger in the animation. You could tell it with user int, okay, this is the first event, this is the second event, this is the third event. That way you could use the same animation event name for triggering all of those. Main path only. The main path only. I will explain that one later. Remember when I said that when you enter, when you give it a shot and all that, you enter a path? The main path is basically, so this one, it only has one path. So the main path is this one from here to this. And in this one, the main path is the one on the left. So it's from here to here. And this one is a secondary path. So when this says, when you take main path here, it makes it so that this event is only going to be active on the main path that goes from here to here, and then from here to here. So if you want to, in the scripts, that is not going to matter. You can just query each event, and it will not matter in which path you are or not. But the path does matter in the animation graph logic. Because the secondary path, if you want to query that event with each event here, because this path here, it creates a new context. And this one here, from here, it creates a secondary context. The event is only going to be propagated to the main context here, which is this one. It's not going to propagate to this one, so whatever expression that you have that queries the event in the animation graph in this path, or whatever that is created from this path, it will not evaluate to true, it will be false. So that's basically what the is main path does. Is that clear? I take that as a yes.
Is someone recording this?
Yeah. I'm recording it.
Okay, good.
I mean, when I'm finished, like, feel free to ask anytime. I have no problem with answering, even if I'm going to repeat myself. Okay, so the queue, I'm going to explain first the basic nodes, then I'm going to be going to other more advanced ones. The most basic node, well, in transitions, that's basically all that there is to it. The any transition is basically the same. The only difference is that it is not from one state to another. It's just general to the state machine, as I explained before. And the same things are happening there, same values. So that's all that you need to know about state machines. There's not more to it. And then you have the nodes. Oh, by the way, I have not explained, like, if you want to play from a specific node, just double click on it and it will start playing. If you want to go to some module that you have here, you can just double click on it and it will send you exactly to wherever that's linked to. And you can use this for search and all that. If you want to create a new node, and just right click, create node, and then you have all the nodes there. Okay, so let's start with, I don't know. Let's do it here. Let's go with the most simple one, which is the one that actually plays animations. You have multiple that play animations here, which are the source nodes. These are the only ones that can play an animation file. And the most simple one, which is the one that just plays animation in a loop or use single time, is the source one. When it has an X, is that whatever you have here, something is invalid. And right now it's invalid only because it's missing the source animation. So whatever animation that you want to play, you will set it here. As I said before, for the people that just came in and all that, you don't play animations by the animation file name and the path. You have animation set instances that you define names for said animation files, and then you register names to it. You register the files to those names and groups and etc. And then you can have multiple animation set instances that inherit from other ones that you can use to switch between animations for the same names, for when you are holding some item, or when you are holding a weapon, or when you are going to enter a new vehicle that you were not into already, or when you want to, well, it depends on your logic, but that's the idea, to be able to switch between animations while using the same names. So that makes it so that you can reuse the logic in the graph, or the logic in scripts. So right now, let's set an animation that actually plays. Okay, this one plays. Okay, so just by having it like that, the default value, you will see that it plays. It doesn't loop. It ends at the last frame, as you can see here. So you need to be careful about that. Like, it's going to end with the frame, with the last frame that it was at. It will not go directly to the idle pulse and all that. You have to handle that in your logic. And the loop tab is used for it to loop, all that. You can control how many times it loops with animation state machines or with a switch node. But we are going to go into that later. And you have interpolate, which is used basically, you want it to interpolate nicely and all that. And this is mostly for when the FPS of the animation is very low and it doesn't match the current FPS that you have, so that it doesn't snap. If you want it to snap, then just disable interpolate. And the node group, as I explained, is used for developers to group nodes together. The tags, as I explained, every node and state machine states, you can set tags too that you can use to query on scripts.
And AnimGraph will be still valid when you have this animation which are connected to nowhere?
Yeah, because in the game you are going to select a main node to play from, and that one is this one. So this one is going to play. This one will never be played. Like
Yeah,
literally
that
never.
means
The only way that you can
that-
make it so it gets played is if you make this one the master node. That's it.
Yeah, that means I can prepare some things which are, for example, not finished in AnimGraph and leave it alone, and it will not broke existing AnimGraph.
Yeah, just make sure that whatever you make, I will say compiles. That is valid.
Yeah. Of course.
Because if you have this node without it actually doesn't allow you to. In here, it doesn't allow you to remove animation. But let's say that you have this one with an animation set. This node is invalid. So you will not be able to use a graph.
Mm-hmm.
So just make sure that that doesn't happen. Okay, so now with predictions. Predictions, you basically give it the name of a bone, and it will take the position of the bone, the maximum, the position of the bone with the maximum distance in any frame. So that's useful for when you have like, let's say, a jumping animation, and you want to see how high the hand goes, before the animation actually plays, So that's what you use predictions for. So let's go with a jumping animation here, just to show that. I guess that's not created yet. Let's find one that actually plays. Okay, so here I'm going to show another node that is very important. Right now, if you want to use the source node to play this specific animation, you will see that you can only give it jump in, jump FN, and all that, and you're missing this one. In DayZ, you can actually ignore using a grouping node and play directly this animation, but here it doesn't allow you. They made it so that you have to use the node. So here you go to create node, and then it was, what was the name? Oh yeah, group select. So here is, this jumping one is not the group, that's the category. When you are going to play an animation in the source, you give it the category first, and then the name, and then you have the groups. This is the group. So what this node does is that it allows you to select the group in the animation. So it will switch. You can see here that basically you can switch between groups for the same animation name. And this is very useful for when you want to reuse the same logic for locomotion, for example, for movement. And you want to, for example, have different states for when you are running, for when you are erect, when you are crouching, when you are prone. You know that the logic is basically the same. What you are going to change is the animations. So changes the groups here. Having these groups here, it allows you to do that very nicely. It makes everything reusable. So let's select the child here, which is source one. And sorry, the column, the groups are this. The column, let's select. And the column, right foot. Okay, and if I play it, you can see now that it actually plays. And it's playing this specific one, the right foot. If I change it to left foot, this one, oh no, I'm playing this one. So there is no left foot, so you can see that I didn't play that one, because there is not one defined there. Let's just copy the same one here. We'll see jumping in. Okay, I think I glitched it. Because it's valid now, because it has animation, it's supposedly playing, but it's having an issue there. Okay, let's go back to Earth foot. And let's use the prediction node. Okay, and you can see there is something important I have not explained about when it comes to animations. The animations are in place. Animations, they are not root motion. In place means that basically the mesh, like with the animation files themselves, the mesh stays in the same place, that's where the name comes from, in place. And then there is a bond that is used for the movement. And that one just moves freely. It's not connected directly to the mesh. It doesn't move the mesh. That one is used for rotation, for movement of the character. And the amount, the difference of the transform of that bone in a frame, that's how much is going to translate when the simulation of the character is being processed, or how much it's going to rotate. And that bond is called entity position. If we enable the bonds, let me play the animation. You want to see that, like if you want to see like if an animation is modifying that bond, you will have to play it from here. Then you click on channels. And when you are playing an animation, a specific file, like when you are not playing it from the graph, you can see all the bones that the animation is modifying. So like if you want to check like if animation is modifying certain bone, this is very useful because the animations here are additive. It is very useful sometimes to know exactly which animation is probably messing something with something that you are blending the animation with. This one modifies entity position. I don't know if someone can help me find it. I will use enable here. Oh, yeah,
Yeah, what's that?
that's something this also doesn't have compared to Daisy. You cannot filter bones.
Yeah.
Oh no, yeah, you can.
You should be able. Yeah.
Okay, this one here is the entity position bone. You can see how it moves. Remember, this was a big misconception in Daisy when people were playing animations in the editor here, that they were saying it was root motion because the player actually moves. But that's because the simulation for that is being processed. And if you want to just literally play the animation as it actually is, as it comes from the 3D software suite that you were using, just click here and change it to in place. And this is how you actually made it in Blender, for example. The mesh stays fixed, in the center, and then it just moves. This entity position bone moves. So when it starts playing, like, you see how it actually moves the character. This is going to be how it is going to behave in game. This entity position bone, I still need to check it here if you can actually change it to another bone or other bones, because in Daisy you can change the name of the entity position bone for a specific skeleton, or you can make multiple bones that they are called movement bones. You can use multiple in the Daisy version, and they work in game as well. I will need to check if you can do that here. To be honest, there is not that many cases where you would want multiple movement bones, but if someone needs it, I'm going to just check it, and whatever I find, I will post it here. This thing about in place and root motion, I'm pretty sure for people that already do animations, this is straightforward. You can see when you're playing an animation, you have properties of the animation. And those properties are custom properties and events. And events are already explained. You can use them for triggering whatever you want, trigger some side effect. The most generic way to explain it is triggering. You can use it for triggering a specific side effect when the animation is being played in a specific frame. You can do that in the animation graph or scripts. And for animation, the way that you define them is through the properties of the animation. You will create a new one by clicking the plus sign here and give it the name and then the payload. And the payload, it can be the string, an int, the frame, the length as well. You can have range events. So you can make it so that the event is actually active from this frame to this frame. That's what you do with the range, with the length. The time and duration is used if you don't want to use it in a frame-based manner. You can just give it the time, and it will literally just calculate which frame it is, and you set it. And then the comment is used for the developer for any commentary there, And also only on main path, we'll make it so that if this animation is being played in or blended in some path in the dimension graph, it's going to only follow the main one. All the secondary ones are not going to be affected by that, so you will not be able to query them in those. And the custom properties, these actually do not do anything in graphs, and they do anything. They also do not do anything in scripts. These are basically used for creating comments for the animation. Like if you have some animation that it has to be blended a specific way, you can add a comment to that animation file that explains, okay, this animation has to be blended with this other specific animation, so that whoever is going to use it, they can see the comment and know that. So that's the purpose of custom properties here. It's not something fancy, it's just comments. Okay, so the group select and the node source, I hope that's clear. Those are the most basic ones. And these are basically the ones that you will use in the most when you want to play animations. There's also other ones like the node post 2. But these ones are the basic ones. Any questions on this? Or anything that you might be wondering relating to this? Yeah, take that as a no again. So let's go with the pose. And this one, the name says it all, is for generating a pose. So it will not actually play animation itself, it will play a frame, specific frame of an animation file. And you will, of a source. And let's select, I don't know, the same source that we have here. Oh, but I will need to connect it to the group select here. I don't really like that you cannot copy the names anymore. Oh, it glitched. Okay, when that happens, okay, this is something I noticed with this version. Sometimes it glitches and it doesn't play anything anymore. So you will have to literally restart it, save it and restart it.
Do you control Shift R to reload Workbench?
I don't want to reload Workbench, I only want to reload this. I tried to just loading the workspace again when that happens, but that still kept it glitched. Oh, it's still glitched. Yeah, I'm going to need to restart it completely. Which shortcut did you say? Ctrl-Shift-R to reload Workbench entirely?
It would be inside the main editor instead of inside animation editor.
Oh, you mean the animations? I don't want to reload the animation. That only reloads the A&M files for, okay, so like, let's say that you imported an animation file and you created your own A&M and you have it loaded here and you imported it again just because you made a change in the animation itself. Then if you re-import it, you don't have to restart this. You can just reload the animations by pressing Ctrl-R. It will take all the animations defined here and reload them. And you can see the changes here. Now, what's happening here is that there is a glitch that it makes it so that you cannot play anything. So I need to restart Warbench. Oh, I completely broke. Okay, let's check the console log. There is no typo, right? I don't see a typo. I want to remove them. Okay, press now. Okay, so the pulse, it makes it so that you take a specific frame of the animation. Well, here is a time, so specific second in the animation, and it freezes it to that pulse in that one. And so right now it's just evaluating to 0. If we change it to 0.5, for example, you can see that it starts changing it. And here below, it tells you exactly where is it playing at. As you can see, the time here is normalized. So 1.0 is 2 is the entire length of the animation. So there is a person that asked, I don't know if he's here, that asked how to do like specific poses and all that for screenshots and all that. If you want to do it through the animation graph, you can do it this way. And you can actually set the time to a graph variable. So let's use movement speed for now.
That's actually pretty neat.
You could literally control where it is being played. Like you can create, like, for example, animation player in game, where you can take all the animations and just play them specifically. You could take a variable here, a float variable, and change the script to start playing it, through scripts in a specific part, and even pause it and all that. But just changing it, Just remember that it goes from 0 to 1 maximum. So whatever you go after that, it gets clamped, or before that. So that's what the pulse nodes do. And this is how you link as well variables to properties of animation nodes. Anything where you can place a value on it is considered an expression. So in all of those, you can literally just have any expression on it, as long as it evaluates to a valid input for whatever you are going to use it for. So this one is very simple. It doesn't have much to it. You have tags as well and all that. It's the same. This in loop out one. This is a little bit more complex. What this one does is actually using events, and you will have an animation. Let's say that let's say that you don't want to make 3 different animations. You don't want to make an animation for when you are, let's say you are going to make I don't know, some gesture, you know, thumbs up. You could make it in 2 different ways. You can make 3 different animations. One for when you are starting to do the thumbs up. One for the looping, you know. So it's basically just you giving the thumbs up, you know. And then one for when you are going to stop, which is the odd one. And then you can play those whenever you want, you know, based on your logic. Or you can just make everything in a single animation file and then set an event, for example, here. Let's say that when it actually, like when you are raising your hand, you know, to give someone a thumbs up, let's say that from the complete animation, it takes from here to here. You will set an event here. It can be named, the event can be named whatever. Let's call it event in, up to here. And then from here to here, it will be the loop animation, the loop part, you know, the part that you want to be looping until you finish the action. And then from here to here, you will make another event here that is the animation end. And this part here will be used for the ending, ending the loop. So the out animation. And that's what this one does. It allows you to select the source animation, which is going to have that. And you are going to set the end event name here, which is the one that you will set here. And the out event, which is the one that we will set here. And an expression for ending, it has to evaluate to a Boolean, so true or false. And when you enter the node, it will literally just play directly from here to here up to like whatever you have as a loop. It will not freeze it as a pulse here. It will play the animation from here to the out one in a loop until the end expression becomes true. When it becomes true, it is going to enter the other part of the animation file, you know, after the out event, and play that. And then this is going to finish, and it's going to send you back to whatever state and this belongs to through the path. Is this one clear? Or not? No questions. There has to be an in loop animation here or something like that somewhere. No, I don't see one here. Oh, by the way, when you play an animation that this happens, it is not a glitch animation. It is because when you are on the T-pose, the actual position of the bones and all that, they are not actually being processed. So this one is going to have an offset and it's going to just send it like over here. But when you start blending the idle position with this and all that, it works nicely. So you need to take that in. You need to know that because if you import an animation from Blender to here, and you are only modifying, for example, the face, it might actually jump over here when you play it alone. But when you actually blend it with an idle animation or with some other full body animation or an animation that actually sets the head in the proper place, then you will not have this issue. Okay, but this one, before I go to another one, is this one clear? Any questions? Something that you're wondering about this? Okay, so now let's start with And what else is missing here? The source sync. This one makes it so that, okay, so you haven't actually checked if it's the same here, this one. There has to be a sync file over here. Basically, the idea of this node source sync is for when you have multiple animations that they are kind of like the same one. You know, they are going to have like the same. Let's say that you have one for running in a specific way, and you have another one for running that is kind of like longer than the other one, but it's basically the same, just slower. Sometimes, depending on your logic, you will want to sync them. You know, just basically the same animation, you switch the animation files whenever you feel fit, you know. But you know that the animation files might be longer than the other ones. You can use this to kind of like sync them based on the events that you have there. So basically what you would do here is, okay, I want it so that the food, when it's in 20% of the animation, it's down to whatever event you have there, like it's going to shrink it to here or expand it. And that's basically what this is. And you can loop it as all the same as other source and names and all that, except this one, because these ones are really, this one you have to control the loop on the state machines. But this one, you can actually loop it and all that, pretty much the same as the source one. You have predictions and the sync line. The sync line connects to this table here. If you want to open it, you have to double click on it, and again, in properties, it will show the properties of it, you know, like everything that is inside it. And that's basically all that there is to this. Any questions on this? Anyone still there?
I'm still here. I'm just barely paying attention. I just woke
Yeah,
up.
I'm still here.
Okay. Okay, all of these are planned. Post you. Oh, this one actually this is better if I explain it with an example. But basically, what this does is you take some animation. Let's say for what's a good example? Let's see. Anyone here has done animation in other engines? In other game engines, by any chance?
Mm-mm.
In other game engines, there is a thing called blend spaces, and basically, this will allow you. It's not a blend space, but it's kind of similar. In this one, you will make an animation. The animation has to be done a specific way, but it will allow you to make it so that you can set up a table of, depending on one value X or Y, you will kind of like create a grid based on these values, and you will create a table that tells the node to take certain frame of the animation when you are in a specific part of the grid, and take that and return that, you know, as a pose. So this is very useful for when you want to handle the head of a character, based on if it's looking certain way on the y-axis or the x-axis, without having to do multiple animations, all that. You can just use certain, like, let's say I want to make it so that when you are in, I don't know, 70 degrees left, you know, and 0 degrees up, you know, when looking, you want to make it so that the head is on the left, you know, you could make it so that a specific frame on the animation is in that, you know. But in here, I'm going to make a sample on this one because making the animation for this is a little bit tricky. It depends a lot on how you are going to make the table, or the table depends a lot on how you are or how the animation is made. But it's easier to make the table first and then make the animation based on that, because if you tell in the table when you are in certain ranges, you know, for these ones, and you tell it, okay, I want to use frame 1, and then you go to a neighbor range in this one, and you tell it I want it to use frame 3. It's going to interpolate between 1 and 3. So if you have something in frame 2, it's going to be messed up when you do the interpolation. So you need to be careful here. So this one is better with an example, like actually doing it Blender, the animation, and then testing it here, and then doing a fucked up example that shows you the pitfall that you can fall into when doing this. So I will explain this one later, but like right now, if you want to know what it does, is that it makes it so that you can, with a single animation, you can make multiple poses based on 2 values, while this one is based on 1 value. So for example, let me play the main one. You see, this is based on 2 values, look X, look Y. Let's enable, I think you need to enable look. Okay, do you see how it rotates based on an angle there? And how when I change this, it also rotates it. This is handled through that node. I mean, you can do it with just plain nodes and all that, but the best way is just do it with a look node. The reason why it's best to do it through a look node, to a post node, a post to node, is mostly, remember that everything that you do here, it is replicated to the client, so to the clients. So if you do something very complex here, it's going to increase the network usage that is needed for every player that might be doing that, that might have entered that state. So trying to not go too crazy with expressions here. Well, you can go crazy with expressions because those are not sent. What is sent is the states that will change of the state of the graph, and then it gets taken on the clients, and then it gets played and all that. So if you use only one node to process this, basically you only need to send these 2 values. You don't need to send anything else. You do not need to even send the conditions or send something generated from it, because it just literally just takes these 2 values. And then it tells the graph in the client that, okay, I'm in this specific place in the graph, I have this context active, you know, and just send this, and it gets evaluated on the client as well. So let's try to find the node so that you can see. And let's see.
And those variables are
see?
hard-coded for character, or you can, for example, add some
you
new variable.
You can make new variables and all that. There is no issue with that. You don't have to follow, like, if you want to create a new character, unless you want to use the vanilla logic, and you're willing to do the whole logic yourself, you can get rid of everything in the graph and just do your own logic. Just remember that you will need to make everything in the scripting side as well, because the vanilla commands they expect certain behavior in the graph, certain variables, certain comments, and they will not be there, so it will not work.
Mhm.
But that's only if you are using the vanilla commands. Like if you want to make your own custom commands, script commands, then you can do whatever you please. Okay, you can see that this one was being played, so this selecting the context there. It's a negative context. When you have a negative context, it means that it is the animation being played. Context that actually process stuff, there will be a positive number. There will be 0 or other positive number. So here in properties, you can see like it's using those variables, and it has a table here. And the table, it basically tells, okay, when y is minus 90 degrees, and x is minus 80 degrees, I want to use frame 0 for the head, you know. And in the dimension, you have that frame 0 is going to be how the head is going to be rotated when you are exactly in minus 90 and minus 80. And then in the next table here, you have minus 90 y and 0 x degrees again, and you have a different one. That will make it so that when you are in minus 90 in the y-axis, in the x-axis when you are in 0, it will use the frame 1. So if you are in between minus 180 and 0, then it will interpolate between these two. And when you are in between 0 and 180, it will interpolate between frame 1 and 2. You know, in between the transform of this one, transform of this. And when you are in minus 80 and minus 180, and you are still in you are in between minus 90 in y and 0 in y, then it will interpolate between frame 3 and 0. So you see how it works. It creates a grid. Think of it as a grid. Is this one clear? We could do a really bad drawing to make it clear.
I think you going very deep, and I'm not sure if everyone understand this.
I mean, they don't give me feedback, so
For me, if I can say, for me, honestly, will be I am very interested how the process is from the beginning. For example, you have model, you have animations on that model, and how you can import this new creature. And for example, which animations you should start. For example, movement, then attacking, and maybe like this example.
Oh no, yeah. Right now, as I said, it's an introductory course. I'm done to.
Okay.
I'm done to go more in depth with specific stuff, with specialized stuff tomorrow or later today, if people are up to it. But right now, I'm trying to explain everything in the graph, how it works, how the nodes work, because there is no information yet on how the nodes work, and it's really annoying to figure it out. For example, even this thing here, you know.
Okay.
So I think that this is why I want feedback as well. Like I think that explaining the basic building blocks first, the foundations first, is better for people to start working on stuff later on, because then they don't have to try to figure out like how this specific node works, how this gets connected, or if they are going to fall through like some pitfall, you know, they might already have an idea of why it's happening because they know how stuff is connected, how it works internally. For example, if you try to use this without knowing what I told you before, there is nothing here that tells you that this is connected to a frame, you know, and that this interpolates directly to this one, and then to this one, and this one interpolates to this here, and this interpolates to this. Also, by the way, the order of the lines here, it doesn't matter. But it doesn't matter what you have on the left here. As you can see, and this is not unequal, and this basically creates the line for minus 90. Why? You don't have to do it with this way, with y. You can have x here and then y. It depends on how you did the animation, actually. And this is why I was saying that it's like making the table first, and then animation is better than just making animation first and then trying to make the table. Like, for example, let's see the animation this is playing. Okay, this is the actual animation. So you see how it kind of like moves its head like from every angle. So frame 0. Let's select the node. Let's open the table. Okay, so you see like frame 0 is supposed to be looking minus 90 on the y-axis and minus 180 on the x-axis. You see how it is doing that here? And then you have this one, which will be minus 90 y. Remember, this is the y-axis, so it's down. And then you had it set up, as you can see here, to it's actually you remember that the x-axis on the next item in the first line is 0, and it tells you that to use frame 1 for 0. So you can see here that it aligns to that, it aligns to 0 degrees on the x-axis. Also, be careful with. You will see. No, never mind. That doesn't apply here. But you will see that this one is 180 on the x, and then this one will be 0 on y, but minus 180 on x. Then 0, 0, and 0, 180, and 90 y. 90y and minus 80 x, 0, 0. Sorry, 90, 0, 90, 180. Okay, I hope it's more clear now, like how this is set up. It's not really complicated. It's just a table, and the table is heavily linked to how you have the animations. And like when you are kind of like in frames, like let's say that you are from here and you go to here, from here to here, it will interpolate you specifically from this transform here to this one when you go like from the ranges that you have here. So it's a very nice way of not having to do a shit ton of nodes there and handling the logic like whatever. So like if for some reason you need to change later on you need to change how much it rotates or whatever in specific cases, let's say that you change the model and currently with the rotation that you had before, it kind of starts clipping with something in the player, then you can just change the animation and that's it. You don't need to change the code here. Or you can reuse. Remember that you can change the animation set instances, or you can change the groups or the columns. By doing it this way, you can also make it so that you can use all those features as well, and you can make it even more dynamic. So you don't have to touch anymore the graph when you want to change something, or if you want to make it so that someone that is going to use your mode as a dependency, you make it easier for them to not have to mess with this. You can see how it blends here. You want to set it back to snapping.
Mhm.
Okay, any questions?
Maybe some. This way, I can make, for example, some idle animation without making this animation in external program. Like, yeah, like they moving with head around, and it's not needed any special anima file, and you can do using this table only.
No, for this table, you need an animation source. Right now, I'm playing an animation here, and the animation is being used for this table. That's how it tells, like, okay, I want to use frame 0, frame 1 of this specific animation set here.
Is this with the new engine?
Is this one?
Is this like with the new engine, like the Infusion engine that just released, or nah?
Yes, it's also in DayZ. It works exactly the same in DayZ. DayZ has the Infusion animation system. It has a previous build, but it has everything that you see here. The only difference is that there is a new node.
You see, like the model, it doesn't look like ArmA 3. It looks too good.
No, this one is Reforger.
Yeah.
But I'm just saying, like, the same information I'm saying here for Reforger, it's also almost the same in DayZ.
I wish I could make a mods, but I'm mentally crippled. Don't ask why. I would make a pooping mod, but anyways.
I mean, to be honest, sometimes those are the most fun mods.
I would have a question.
Mhm.
Is it possible to show give UI the animation in the editor, like in the trailers or in the pictures they released for the whole ArmA Reforger thing on the Steam page, YouTube.
Oh yeah, you are the one that asked for stances, right?
Yes,
Free
yes.
stances. Okay, I explained that before. I recorded everything, by the way. I will upload this later on.
You recorded it?
Yes, I'm recording everything. I explained that.
Nice. Thank you.
It's actually related to these post notes. Not
Okay.
this one. The post 2 is mostly for creating brain spaces, like what I show here. Let's see, post. Okay, we created this one, which basically just takes a specific animation I set here and freezes it in a specific time. You can see how it's not moving, it's just frozen. And you can control it. I set it to be controlled with the movement speed. You can create a custom variable, or you can just freeze it directly with a specific value. And you can see how you can freeze it. And this will work in game as well.
And can you now like give a UI in the editor in the world, so you can see it when you're walking past the player or AI, that it has like a idle animation or something like that. Is it possible to?
Yeah. You can basically make the logic here for it to play whatever animation you want, or whatever specific frames of an animation. It's completely possible. And
then script it for the player or the character.
You can even make a custom graph that kind of like makes a specific behavior that is not even normal, like that you will not be able to do with the AI behavior thingy. Just for the video, if you want to make a video or if you want to make a screenshot or whatever.
Yeah,
Okay.
right. I would like to make a campaign or something like that, and use animations for characters. Did you show that before, or?
Right now I'm showing the building blocks, the foundations, and all that. But later on, like depending on what people want to do, I will be making like
Okay.
samples in
Okay.
streams like this, you know.
Nice. Okay. Thank you.
So the post nodes, that's basically what they do. You know, there's only 2 post nodes. The post one, which is with us I already showed, and this one that I just showed as well. And these source nodes are the only ones that can play animation files. There is, coming back to hunters, you asked if you were able to make an animation without having a file, right?
Yeah.
Okay, there is a way to do that. Let's see if I can find it here. I think they actually changed it to procedural. Hey, Jeko. You there?
Yeah, hello, what's that?
Do you want to know what the procedural animations are?
Yeah.
They are the... You know the... Do you remember that note I told you about in the animation graph in DayZ that allows you to just take certain bones and move them whatever you want with an animation file?
Yeah.
That's the procedural node in here.
Okay.
It's renamed. Okay, so in DayZ, this node is actually called a nim node road move. In here it's renamed to procedural. And basically, let me go back to idle here. Oh wait, this is breaking it. Okay, this actually needs a child, so let's set... I don't know, some idle. Okay, when I say that there is only there's only these nodes, in source. These nodes are the only ones that can play animations. This means that these are the only leaf nodes. Remember that it's a graph, and you have leaves, and you have leaves, and leaves are basically the ends, of whatever path you have here in the graph. And so these ones are the only ones that can actually output something for the animation system. Like those are the ends. So all other nodes, they are going to require you to have a child, except the source ones. So the procedural one, even when it allows you to create some animation without using some animation file, it still requires an animation file in the end for the child node. It can be anything. So in here, you have the bones, and let's say that you wanted to rotate the head, right? Hunters.
Yes.
Okay, so just type the name of the bone here. And you have the axis that you have the, in the transformer, you have in local space, model space, the space of the parent, or some pivot. And let's use local. And let's rotate on the x-axis. And then you have the operation, which is rotate or translate. Reset, rotation, translation, that's new. I will check what they are later on. Let's use rotate. You have the amount. We don't need a pivot right now. Oh, no, well, we actually do. Let's see the hierarchy of the bones. Okay, this one is new. I don't think that would make it work. Wait, did this break it? Let's see. Oh no, don't tell me glitch again. Okay, that other node broke it. I'm going to just connect it to this. Okay, nice. Okay, let's use the look X for this one. So in here, you will be able to. Okay, so you will have like a set of bones that are going to change their values. You have an expression. Whatever value you have here, it's going to technically be multiplied by whatever you have here. So this controls everything. Just remember that it's going to be multiplied. So the amount here is kind of like the weight of how much this bone, well, this specific, well, you can have the same bone multiple times, but this specific, let's call it description, is going to be processed based on this. It's the weight, you know, how much is going to move in whatever setting you have here, based on the current expression here. This value can be also an expression, but let's give it value of 1 right now. In the expression, let's use a graph variable, the look x1. Let's play it. Oh yeah, I have this pose. Okay, let's play it and test. Oh wait. Okay, do you see? Let's change it to.
This is like some coefficient.
See, it's the weight, you know.
Oh, very nice.
And okay, I'm going to save it before it crashes. Okay, and you can create another instance of a bone. Let's use this time spine 2. Let's give it an amount of or weight of 0.2. Then rotate. Okay, so now you can see how all these are tied to this expression here. See?
Oh.
The head is moving as well. So basically, you can use the expression here as kind of like the time value, of when it's playing, So you can use it as the current time. You can set the weights here, the amounts, as how much you want to move it based on that time. See? So what you were asking, you can technically do it. You can technically do a whole animation this way. It's a little bit like doing model CFG animations. The only issue is that you will need a lot of nodes if you want to do a complex animation, and not to mention how complex it will get to handle the logic for how stuff will play and when it will stop and all that. You can clamp values as well in the expressions and all that. You can even use trigonometric functions. There is even random number generators, stuff like that. It has its own set of functions that you can use. So basically, that's what the procedural one allows you to do. It's not only rotation, by the way, it can be translations. This is new, these parts, so I will not even attempt to explain it because I most likely give probably wrong information on that. So this one will have to wait until I find out like how exactly they work, or when the actual docs, the official docs comes out, or when someone else already messes with it. So, any questions on this one? Also, who's still here, because I know it's late for some people.
I am still here. It's really interesting.
For example, as you can see here, it's late for me.
Yeah, I'm same time zone actually.
Yeah, in Europe is close to lunchtime.
Yeah, here it says 8 p.m. Close to 8 p.m.
Actually, I have my food here cold. I didn't eat it. I'm going to reheat it some. Okay, so if there is no more questions in this node, we'll go through another one. Basically, that's just it. Is like for people that have modeled before, the easiest way to recognize to get familiarized with this one is it basically behaves like model CFG animations. And you know that you have the animation controllers, which are basically variables that you give it to it. The animation controllers are basically the expression here, and this one is for all the points here. And it amounts, as I said, you can use expressions here, not just a number. So you can give it even other control. So this is very similar to model CFG animations. Also, remember, these, whatever you add here, are expressions. So you can add stuff to it. See?
Actually, try clicking the double dot after the expression. It will ease up your development.
Oh, yeah. We opened it before.
Sorry.
To get like for this command. To get like the stuff here and all that.
Yeah, sorry, I haven't been there at the beginning.
Maybe regarding this is command, I see how are vanilla commands, but how should be written here is command my custom scripted command? Which name should be there?
Give me a sec. Okay, let's create a new command. It can be whatever name. Let's call it test. You will see it here.
Mm-hmm.
And you have the default value, which is the force value. And if you want to trigger it, if you want it to trigger something here or be using an expression, you can just do, in this case, well, this one is for boolean, this one is for float values. Well, let's just say that this was a boolean expression. You can just use is command, and then you can just give it tests here.
Yes, this I understand, but how I can connect this name into scripts when I have a scripted command which is called, I don't know, something.
I will go into that later. I'm not explaining scripts yet, but you will basically, okay, in scripts, you have, when you create a custom script command, script, by the way, it's different. Animation command is different than a script command. So you will create a script command in scripts, and in there you will have to bind. When you bind something, it returns to you an ID, an integer, which is the ID of whatever you bond to it. So you need to bind, like you need to use a bind command. In there you give it this. There is a argument for it, you know. And in the argument you give it a string, and that string is going to be the name of the command, the exact same one in here. And then it gives you that identifier, and then on the script command in pre-anim update method, you will be able to see if the command has been triggered when that gets processed. So that's the way that you will connect it in scripts.
Yeah. Okay. Thank you.
Okay, this one, I have explained it to some people, and for some reason, I don't know if I'm explaining it in a bad way, but people always seem to have issues with this one. This is relating to the variables that you have here, these ones. And it makes it so that when you enter this node, after you enter it, like whatever the behavior of the variables, after that, they are going to be cached or changed. For example, let's say that this is connected to, I don't know, to this procedural one. Remember that we are using lookx. Let's play it again so that you can see the behavior again. Oh, no, it was not this one, it was this one. Okay, remember that it moves like that? That it actually moves. Okay, we go here to the var update node. We go to the var update groups. We create one. And it tells you to use a variable name. This is not an expression. You have to give it a variable name here. Let's just look x. And right now you can see that it's blocked. What happened here is that when you enter here, depending on how you have stuff set up here, it's going to record the previous state of the variable before you enter this. And it's going to decide to not send it to the main path or to the other paths that are connected to this, That is to the childs, to the children. And also when it's going to do it or not. Let's enable on init. You can see that whatever value I had here, which is this one, it allows it to be sent here. Let's change it. You see that it doesn't do anything. Let's enter this again. Well, let me actually wait. So see, nothing. Let me stop it and force the initial value to be, I don't know. I mocked the wrong thing. Let me make it 20. Do you see how I started there? But I cannot move it anymore. That's because what this does is it creates a temporal variable. It takes the value that the variable that you set here had before entering this node, and it caches that variable there. It saves it into that temporal variable, and then it uses that temporal variable as the look x in this case for all the children that are there. If we set it update on main path, it will make it so that, remember when I talk about main paths, what they are? If people that already came here and they don't know what the main path is, I'm going to upload the entire stream later on. But the main path is basically like you have, let me stop it. You have paths from here, connections. The main path is the main connection that this node has with something else. The main connection is always the one on the left. It's also always the one that says child only. And then when you have other stuff like, for example, in the queues, you have other children that you add with groups like this. Those are not going to be the main path. The main path is going to be the one on the left. So when you set this one to be on main path, it makes it so that that temporal variable that was created here for look x is not going to be used for this path here, but it's going to be used for other paths that are not the main one. Update on init, it makes it so that when you enter this state, when it gets initialized, it actually allows the value that was here to be cached and used to whatever is here. If you have on main path, it's only going to be sent to the main path. So it's only going to be sent there. And update on blend out, it makes it so that when you are going to exit it, for example, this is being blended with something else with a blend node, that's going to be used. And this max difference per second is used to kind of like create kind of like a cooldown for it. Okay, is this one clear? Or did I make it confusing? Anyone there?
Yes.
Okay, I thought I was lagging.
There's quite a few of us here.
Yeah, but almost no one talks.
Sorry, I'm double muted because I'm recording myself as well, and I didn't want to leave any background noise in.
Oh, yeah, I want to know if it's like if there is any question on this one, because this one is really useful. It might not look useful right now, but it is really useful.
Maybe try told us some example where can be this kind of node used.
So okay, so you can use it for, let's say that you have some variable that changes and you want to lock it. So let's say that there is certain variable for movement, and you made it so that the player died, In that case,
for example,
in that case, if you want to use physics or something, you might want to not allow that variable to still be processed, because you want to use physics at that point, to fractals or whatever. And you could and you don't want to disable simulation. When you disable simulation, the animation graph and the animation system, they are processed there, so it just basically freezes everything. But let's say that you don't want to freeze it, because you don't want to make it so that the player actually dies. Let's say that you want to make it so that the player actually just passes out, So, or they just get down, they can still move their head or whatever. You would want to freeze certain stuff here, because it's easier to freeze it here than to freeze it in scripts. So you can restrict movement here, you can make it so that people cannot actually move anymore. People cannot move their legs or whatever, or entity position bound just cannot move at all, because you have blocked the movement variable there or whatever. Or if you wanted to block some variable to be a specific value all the time until you exit this node, then that's somewhere where you can also use this. You can also use this for making a stance system, where you will, if you want to make it so that it's not like, how to say it, continuous, if you wanted to make it discrete, so in steps, you can use this. If you don't want to use animation states, so if you don't want to use a state machine for it. Is it more clear now? This one is better with examples. I will make sure to give an example on this one later.
For me, it's every time better see some example, and then I will better remember for that.
But basically, what it does, like, it just takes a variable, and it just caches that variable, and it decides on which paths, on which children to propagate that variable to, that case one, and on which ones not to, and propagate the actual one, the global one. That's what it does. Okay, these buffer ones. Remember when I was talking about context and all that? And, well, it's context for those ones, but the buffers one, and they basically allow you to save the transform of the bones, that you had to be reused later. So you could have this buffer. Well, not here because it's a leaf. Let's say that it's connected here. You could have this buffer up to here and save whatever it is in terms of bone transforms and all that in here to a specific buffer name. So you have here, this node name is different. This is only for the editor and the connections. But this buffer name, you can give it a name, and all that information is going to be saved into a buffer with a name, and then you can later on use them somewhere else by calling buffer use. So you save all those transforms, all that information there, and you can reuse it somewhere else by using the buffer name there. So it just copies whatever is up to this point, saves it to a variable, then you can use that variable there and use whatever was copied there into this one. This is very useful for when you are changing between states and all that, and you want to keep certain transforms. And for starting, for example, for a starting pose or whatever that was made dynamically with some logic that you had somewhere, you can use this for that. And that's all that there is to this one. Well, these two. Any questions on this one? Okay, I think that's a no again. Okay, so and now let's go to the blend ones. These ones are for blending. Well, these ones are basically to do the additive animations part. Additive animations is basically you have a bunch of animations and you start to layer them on top of each other. You start to blend bonds, like specific bonds that this animation have, one on top of the another and all that. And this is very useful for not having to make like 1 million animations for when you are turning or running, or when you have a weapon on your hands and all that. You can just take the specific bonds that and the transforms those bonds that are required for only the gun, for modifying the play animations for it to be holding that gun. I just blend it on top. And then blend other stuff like the head and all that to be able to just move it around. We just modifying certain head bones and all that, and neck bones. So that's basically what you use the blend nodes for. And there is multiple blend nodes. The most simple one is blend. And this one, it will have two shells. Shell 0 and shell 1. Again, the main part is the one on the left. And you have a wait for it. And the same as in the transitions on the state machines, you have a blend function and the motion vectors. You can optimize like which path is going to take mainly, when it's being based on the weight and all that. And the main path as well, which is the last one as I explained. Which is, in this case, is shell 0. So let's take two animations. Let's take the swimming one again. Ooh. Well, I deleted the main one. Yeah. Which other animation should we use? Okay, let's reopen it. Oh, well, it might be these nodes. Yeah. Okay, let's make sure all the sources work first. Oh, by the way, this here again. And this is not a glitch animation again. It works this way because it's supposed to be an additive animation. It's supposed to be an animation that is blended with other ones, which is basically what we are going to be doing. So when you see stuff like this, it's not a mess up animation. It's just that it requires for it to be blended with something else. Okay, let's blend this one with the, I don't know, some movement animation. So let's take those. Which one should we use? Okay, remember to check in the dimensions, the group, and the column. And remember that you have to use a group node for that, for it to play, because otherwise it's going to try to go to the first one, but there is no first one, so it will not play anything. Okay, place now. Okay, now let's use the blend mode. Okay, this one is most simple one because it only blends between two animations. You can have a blend mode that blends with another blend mode, and that's source node, or a blend mode that blends with another blend mode and another blend mode. So you can stack them together like that, or you can have a blend mode that blends with a state machine, that also blends or uses other stuff, So it's just basically takes one node and another one, and it blends together the whole context that they end up giving you. So let's add the Charles now. And as a weight, let's use movement speed again. Yeah, let's just call it. Oh, remember to say to loop when you need it to loop and all that. Don't forget about it. Okay, and see, this one is basically a hit. Okay, do you see how it is blending based on the weight? Okay, so it is blending based on the weight expression that I have here. When this weight is completely 1, depending on if you have it to optimize min or max values, these are referring to the transforms of the bones. Then depending on that, the value of 1.0 is going to lead you directly to only play the one on the right, so child 1 and child 0. It will be played with 0 weight on it. So right now, let's do that. Let's just optimize min and max. Okay, see? But also see what happened here, because remember that when we play this animation alone, this animation, it doesn't have keyframes at all or anything for the head and some spine stuff, which is why it kind of looks like it's kind of like scaled down. So if you want it to blend nicely, you need to give it an idle animation or some animation that actually modifies these bones, so that it doesn't go this way. So you can just set it so that it just literally just combines with this nicely, Just make sure to, when you don't select any, like optimize min and max, when you have it to 1, it will blend both of them. But it will, the weight here, the weight is actually for the right node. So if you have a weight of whatever value you have right now on movement speed, which is 3, it will make the rotations and the translations of the bones in the animations that are in this shell. It will make it 3 times as strong as they are normally. So be sure to not go overboard with the value there, because it will multiply the strength of those transforms. See? So for example, you could use this. You could take, let's say that you want to make like some mode that creates some injured states and all that, and you want to make it so that the player cannot do the specific animation, for example, completely, like if it was hurt, like it tried to like raise his hand, but it wasn't able to because it hurts or whatever. You could sell a blend that basically doesn't allow him to do that, like full one will be this, and injured one will be this, or this.
And using this blending, you can, for example, make combining sitting in vehicle and allowing have weapon in their hands and.
Yes.
Uh-huh.
Just make sure that the weapon enhanced animation, the animations that you are used for the weapons, make sure that they do not modify the legs or stuff like that, because otherwise it will start moving them. So if you want, we can just test that right now. I know, but we need to play the dimensions.
It was just idea. Don't waste.
Yeah, but that's the idea, like to reuse animations, to take some animation that is already there and modify specific stuff on it just by laying something on top.
Yeah.
That's the whole idea of editing animations. Editing animation is not something new to DayZ. Like if you search in YouTube for editing animations examples, you will see exactly the type of stuff that you can do. If you search in other game engines, you will also find it. You will find like good resources on that you can use here. The only difference here is that the way that you set it up here is different in those. So now you have the blend in, and this one is basically the same one as this one, but this one allows you to blend n nodes together. So you can have n childs with it, and each one is going to have their own weight, which is the thresholds here. And you have a main one, but let's add a children. You can see how is you add multiples, starts creating them here. In here you will only add the child, and in thresholds, this will be the threshold for the first children, this for the other one, and this for the other one. So let's use these ones. By the way, another node can connect to other nodes that are already connected to another one. And if you play, remember the whole thing about context that I was talking about. If you think that because this, let's say that this is playing, it's connected to this one, and this is also playing, it's connecting to this one. The context of this one that is connected to this one will be different than the context from this one to this one. So it will not merge. You will end up with different logic on the path that it takes from this to whatever is below this than the path it took from this to this. Basically, what it does is that it takes this definition of the nodes, it creates a new instance of it, and it connects to the instance created by this. And then this one, it takes the definition of this one and creates another instance, and it connects it to the instance of this one. So be careful about thinking that connecting this one with this one, it will give you the same path. It will not. It's different. So just be careful about that one, about doing that. Is that clear? Also, if someone doesn't understand something because of my accent, feel free to ask me to repeat.
Всем привет.
I think this might need. Yeah, it's a group. Okay, you can see what's happening. Check the thresholds here, and check the value of movement speed. Do you see what they do? When you select cyclic, oh yeah, cyclic needs another one. And you see what happens when you change what is cyclic. It makes it so that when you go past that last value, it sends you to the main path again, which is this. That's what this one does. It will not allow you to play the graph at all if you have this selected, if you don't have an extra threshold. So like if you have 3 children, you need to have 4 here if you have this enabled. Because this last one is the one that is going to be used to cycle again. And the blend function is just how the easing is going to take, the blending for when you change and all that. Only be careful that. Do you see how it directly just changes? And then it starts to blend a little bit. You just be careful on that, like how you set it up. It's going to change also based on the weight. Okay, so is this one clear? Also, the blending that you see here, that's when you are changing dynamically this. If you change this, for example, from this value directly to like, I don't know, 1.5 1.3. It doesn't do any transition. It doesn't blend at all. It just changes directly, and it blends stuff directly. It doesn't interpolate in the sense of making an animation that it makes a change between this value to this other in a specified time. It just instantly changes to it. So if you want to interpolate, to do an animation, transition that is interpolated, you have to do it with transition in a state, between one state to another. If you do not want to do that, then you have 100%. You 100% have to do it through scripts, and that's not fun. That's not fun, specifically when you have to do it for the client that is doing the stuff and then on the server, because there could be, like, depending if there is lag or not, there could be some issues there with synchronization. So always try to do everything on the graph, because it's going to be replicated nicely. You will not have to worry about networking at all if you do everything with the graph, where it makes sense to do it in the graph. Because you can also mess it up, like if you do very nasty stuff here. Okay, so is the blend end node clear? Any questions, or any questions about where you will use this? Well, I guess no. Okay, this one, this is also for blending, but this is based on triggers. And basically what this does is that you will give it like the children, like basically the same thing as this one. The one that's the main one, and the other one that you will blend to. And you will have a condition that, well, let's first play the trigger. Okay, the blend time, this one will actually do a transition when it gets activated between one and another one. This is trigger base. It's not the same as this one or the blend one. Those are based on values directly, and this one is trigger based. That's why there is a blend time, because it cannot like transition from one part to another based on the trigger. The trigger on is basically when to go from the left side to the right side, and that's going to be active until you leave some parent node, or until the trigger off. Well, when you leave, it leaves even the left side, it leaves the entire path. But let's say that it's on right now, it's running, and the left side is being blended with the right side. If you want to disable that and go back to only playing the left side, you have to make this trigger off to be true. When the trigger on comes through again, it starts blending with the right side again. And the condition is basically to allow for any of these, because there might be times where you might have variables that affect these ones that you don't have to be affected right now because of certain conditions that you have in scripts or on your logic in general. And the optimize min and max and select min path, they are the same as this one and the blend one. And the possible is the same as in these state machines. So, for example, let's connect, which animation was this? Okay, let's connect this one and this one. it has now entered this. If the variable that is here, the expression becomes false, it sends you here directly. You set it true again. You send this true. You will see that it sends you back to this, but it's not like doing both at the same time. You can see that it's kind of like struggling here. It's because it's becoming on and off, on and off, on and off every frame. And you don't want that. So basically, in these triggers, what you usually want to do is not have like something that will continuously be true or false. Well, you want something that might be continuously false because you don't want it to always be active, but you would want to use stuff like is tag, is event, is command, instead of use a variable, or if you use a variable, use a boolean directly. Or if you're using a float or whatever, make sure that you are using a range or something for it. Any questions on this one? Or not? No questions?
No questions from me.
Okay. So like these three blends are the most common ones. Let's go with the Q one. This one is basically a queue. It will queue like, remember about context. It will allow you to queue multiple contexts, and it will not do them at the same time. It will do one first, and then when that one is ended being processed and all that, when you make it so that it doesn't get processed anymore, it will go to the next one that was queued, and then to the next one, and then to the next one. This is very useful for when you are going to do actions and you want one to be done and then another one to be done later, or when you have stages for performing some animations, you know. Yeah, like you want something to be done first, and something that the player does might actually affect that you're already doing, but it will not affect the next one. So you want it to be queued, you know, like in stages. You could use this to do that. Or let's say that you have some action system, and you want the player to be able to queue one action, and then to queue another action that uses the same part of the animation graph that is the children of the first action that you did. And you want that to be done again later, but with other stuff, you know, with different contexts. In that case, you can use the same state machines or whatever, you know, whatever children. With the same logic, you use process differently by queuing them. Let me make an example how this is managed. Let's use the same nodes. I'm going to delete these ones because it's becoming a little bit ugly here. Oh no, I deleted it. Okay, you can see here it goes to the main path if nothing is set to be queued already. I only have like one path to be queued, you know, like this children here. With path, I just mean like all the entire chain of nodes are going to be processed just because of these children. Let's play it frame by frame so that we can see stuff more nicely. And this expression here, it can be like some conditional, like whatever you want based on the variables there. When it evaluates to true, okay, it has to evaluate once, because whenever it's true, every frame, it queues it again. So let's do, where do I have controls? Here. Let's do a comment. Oh, let's actually use the test command. Oh no, I don't have it anymore. Well, let's use command locomotion fail. Okay, in here you need to check first, like if the command is even active, you know, and then get the command value. In this one, we are just going to check like when we fire the command to queue this specific path here. And that will be done when that is 1. When we call that with 2, we're going to end it. So let's test it. So let's go here to controls. Let's call it with -1. Nothing. See? And even when this is false, no, you know, when this evaluates to false, the start expression, this is still being processed because it was queued. So if you want to interrupt it, you know, to stop doing it, then this expression here, the interrupt expression, it needs to be false. And we set it to be false when this command is active and when it evaluates to 2. And it actually blends it nicely with this. Also, check this here. It tells you what's queue already. If we call 1 again, something else is queue again. If we call it again, see? And you see that the next stuff that was queued, it is waiting to be processed. So let's stop the one that is currently being played. And now the other one starts to be in queue. It starts to be in process, you know, and the other one's still waiting in the queue. Okay, is it clear what's happening now? It's kind of like a it's kind of like a task scheduler that does stuff after one is finished, and you start like kind of like creating a list of tasks that you have to do one by one, and you will not do the next one until you have finished the first one that is there. And let's say that we have another children. Let's make another one. Let's connect it to whatever. And let's make it so that it gets triggered when that command is free. And it gets interrupted when it's 4. And start time to be 0. Wait, what's wrong here? Okay, so we already queued this. It's being processed because it's the first one in the queue. Let's call another one of these ones. You can see here, it's queued. It's a different context, as I explained again. Like, when I explain, like, when you go to the same node again, processed by something else that is being added, it creates a new context. You can see it here, context 2. So they are not processed the same. Like, you need to be careful about that again. And now let's call the third element there, which would say it to be 3 to enable. See. And now let's queue the one of the first again. And again. Okay, and let's tell it to stop one of the second elements. Nothing happened. And nothing happens because they are not being processed. Only the first, well, the element 0. The main path doesn't get taken as an element. This one is element 0. This one here. That one is the one that is being currently processed, and that one, for it to end, it needs to be 2 with this value. And then it starts with the next one. This case is still 0, so this one. So let's end it again. And this one is 1, so the second item. It will not end with 2, it has to end with 4. Okay, so it's basically kind of like a list. And you allocate stuff to the list in order, and then you state stuff from the first one. And then until that first one is not finished, then you cannot go to the next one. So that's what this one does. Any questions on this one? Okay, if there's not, I'm going to take a break now because I want to eat. I'm going to be around later today if anyone wants to continue this. I'm going to compress the recording and then upload it. I will try to compress it without actually messing the quality that much. But I will stop it for now. Like, if anyone still has questions, anything, they can send me a DM. But I would prefer if it gets asked here in Discord so that everyone else can see it. But for now, that's it. I will probably continue like in some hours, like if people are still around, or maybe later, or maybe tomorrow. It depends.
Thanks for taking the time to do this.
Yeah, he's gone. Oh, he's still there. Thank you. That was informative.
Okay, let me check the recording. Let's see if it actually recorded the audio. If not, then it has to be a big file. It was what, like 4 hours?
All right. Thanks for that. I'm out.